That is. Okay. Do you have some question on about yesterday? Something to ask?
I mean, I tried to watch the video, but it was very noisy. But I
Yeah.
tried to, so maybe like recap from yesterday. Or
Okay.
something.
Anyway, when you have time, try to play a little bit with the machine, huh? So try to make
Okay.
try
Yeah.
to make something. Doesn't is not important what. Of course, we just saw something about the holes, so not more than the holes, but try to play a little bit because the success is if you spend time in the machine. Of course, this is the
Yeah.
okay. So
Okay.
for today, I want just to show you how to make to use the router a little bit, and if it's possible, and if you have the USB key of AlphaCam, we can also make the upgrade on
Yeah.
the other computer.
Yeah.
We don't have the key yet.
You don't have the key, okay?
We,
Okay.
No, because Tommy has it and we didn't get. We couldn't get it anyway.
Okay,
We're gonna
no
try
problem.
this weekend.
Okay.
So we tell you when we have it, so we can.
Okay,
plan.
good, perfect. Okay, so we take a look just some moments to the router. Yesterday we see the first icon that we have is the possibilities to make holes on the machine in every phases is possible. So phase 1, phase 2, phase 3, up and down. All the parts can be, you can make some holes. You can repeat the holes here. Yesterday we just checked about the fitting. So to close the argument of yesterday, you remember we make a very fast repetition in XX, where we put the starting point, the ending point, the interx 32 millimeter, how many millimeter in Y, and the depth, for example -10, and the diameter. And these create automatically all the bits on your panel. As we said yesterday, the last point here will be not in this dimension because for sure you don't have the right position. To understand the position, I repeat, you have to go inside in the way to measure it. This. If you click here and you go and you press in the right side of the mouse, you can also ask the system to activate the snap on the program point. And if you go near to the point, you can see the system will give you the position in X and Y. And in this example, we are perfect because we are 900. But okay, if I try to move the dimension, you will see, for example, sorry, this is okay, I want to move this, okay. I moved the length 50 millimeters more, but if I check for the position of the last holes, let me see. Okay. Entity and programmed point. It's anyway. It's 932. Okay, so we have one board more, but it's not LF minus 100 because you have 18 millimeters less. So the line is here. But so the question is, can I make a program like this with a repetition on? Sorry. Okay. Can you hear me? Hello? 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 Okay, Niklas was out. Now maybe I have to do like this. Let me see.
Vad fan?
Hello? Okay.
Okay,
No.
sorry.
Now, no problem. No problem. So the system is, now the question is, can I make something that, because in this position, just a second, in this position, for sure I have 100 millimeter, and here not, I don't have. So my question is, there is the possibilities to make repetition automatic, like in this case, so using the fitting, but I want the same measure here and here. Is it possible? What do you think?
I guess so.
Not really, because it depends on how many times 32 is. If you divide 32.
Okay. So it's
You have to
it's true.
count.
It's 50%. It's not completely okay. The answer. I will try in this way. For example, if I program the system in this way, the starting point of my line is LF divided 2. And the end point is, anyway, LF minus 100. So I program just from the middle of the panel up to LF minus 100. And now I want to copy the same line and paste. I select the second, and I want to say the starting point is anyway the middle, but and we arrive up to 100. So I put 100 and 100, both parts, okay? So in this case, the starting point and end point will be the same, perfectly the same. Also,
No, it's not necessarily 100 millimeters.
of course, it's not 100. The measure of the last and the first hole is just equal. It's just the same.
Yeah.
It's not 100. It's near
so
to 100. Okay.
No. Yeah, so close that it can be, kind of.
Yeah. So in this case, any kind of dimension in length that I want to put, I know for sure the number of the holes it's more and more, but this measure for the up to the first panel, the first solid, the first hole, and the last is completely the same. Every time is the same. And if you want, I can copy everything. And I can copy and paste again. So I have just to move the y-axis. Also in this case can be HF minus, for example. Yes, and this one with the same position in Y. So with some click I have a lot of repetition and completely parametric, because the same thing can work also if the panel is completely different like this. Okay, so in if we speak about the board, here you have a lot of kind of board that you can do. The difference is just the repetition, and for example, I can decide to make to repeat. It's not the fitting. This is the fitting. Fitting means give me starting point, end point, and interacts between the holes, and I will put automatically all the holes inside. I don't. The software doesn't ask me anything about the numbers. He arrived to the numbers himself. If I want the repetition like this, and in this case is repetition in x-axis, so horizontal repetition, the software asks me the starting point, for example, I don't know, 50 millimeter, sorry, and how many holes you need. In this case, I ask you directly the numbers, for example, 10, and the interacts, for example, 32, and the position in Y, for example, 500, and in Z, how many millimeter you go in, for example, -10, and the diameter can be 10. This is another way to make holes and repetition. In this case, I say to the software how many holes you want. So the numbers is on my end. And the same way you can make a repetition also in Y, so in vertical. You can make repetition and fittings in X and Y, so in diagonal. And also in a circle. So you have a lot of way to make holes, and you can play with this. It's nice. It's and very, very easy. Just open, just try, and that's it. Not a lot of things to say. Okay, now I come back to the router, because the router, it's a lot of things to say with the router. It's more and more complicated than the holes, because of this. Maybe when you use the router, we use AlphaCam for this reason, because it's more difficult. Anyway, it's good to know about the router. It's the base. So if I have to make to format the panel, so go around the panel to have a good dimension and 90 degrees in the corner, and so on and so on. It's good to know because you can use it, in my opinion. So I make a new program, and now we want to make a program where we format the panel. So the starting dimension panel doesn't make any sense. What is the measure, in my opinion? So if the panel is 1010 millimeters and 610 millimeters, so we have 10 millimeters more for length and for the height, it doesn't matter for the program. So we don't write down that it's 110 and 610. Doesn't matter. I write down just the end measure. For example, I want the end measure of the panel will be 1600. That's it. And I came on the first phase because we work in the first phase. In the phase 1, we open the first command when we use the router, and every time that we use the router, we have to start with this. It's called setup. In setup, I have the information for the first point. The first point, for example, will be here. Remember that it's this is the x-axis and this is the y-axis. And this point is the 0. Means everything is over this point in this direction, x plus 1, 2, 3, 4, 1000, 2000, 3000 millimeters. So if I'm in this position, the y-axis, it's the first axis that you have to set. What is the number that you have to put here? If this is 0x, if I am before...
minus.
Yes, right. Right. For example, minus 50 means minus 50 millimeters. Okay. In Y, I put just 0. I will explain better why is enough 0. And the depth. because I have to make to format the panel, what is the right depth that I have to write down in the software? What do you think about? What is the number that I have to put?
0 or more or less.
Okay,
Minus.
if you put 0, the router will touch more or less the surface of the panel. So I don't go down.
Minus.
Right. So you need minus, for example, 19.
20 or 19.
Okay, or 20. Maybe it's better 20. Because it's better 20. Because we know the thickness of the panel is 19. If you put 20, you have 1 millimeter more than the thickness, so it's better for the cut. It's better because it's completely clean. Okay? And we are sure that we clean everything. So, right, minus 20 is a good answer. Or you can also write something like this if you want. It's the same. What is this? Minus S, S is the thickness, minus 1. Why I'm writing like this? Because if I write like this, all the format of every kind of panel, of every kind of dimension, of every kind of thickness I have in the future, I just open this program. Because this program can manage any kind of dimensions. And the result is...
Did you say S?
Minus S is
What did S?
thickness.
Yeah, but the S, what does it stand for?
S is the thickness.
Yeah, but what language is it? S for?
It's in Italian. I'm sorry.
I mean, okay. No, I just want to know. So it's easier if you know kind of.
Yeah,
if it were to be in a team.
99% of the things it's in international language. S remain,
Yeah.
or maybe also Z is
What is
working.
S?
Maybe also is
So, no, but I mean,
spessore in Italian.
Okay.
Maybe also Z is
So
working,
now I
but
have to learn Italian.
yeah. So you
Yes,
must learn
okay.
before Italian and then the machine. No, I'm joking. Okay, it's minus S minus 1. And the tool number, it's the tool number that you have on the router. Maybe I don't remember it. And about the tool in the machine, we have a complete lesson where we speak about the tool configuration and how to call a tool and why the tool is calling in this way or not. But if you don't remember, don't worry, because I have here the possibilities to click on this little square.
Okay.
And here I have all the configuration in the machine of the tools. In this page you have all the tools, so the tools for the router and the tools for the boring head. It's a completely different tool. Remember that the number, start the number from 1 up to 200. And the number between 1 and 99 is just the boring tool. So in this case, we don't need the boring tool. We need the routing tool. And the routing tool starts from the number 101. This one. From this up to 200, you have all the routing tool. And you have here the diameter. For example, the number 101 is 15.5 diameter, the length, and some parameter, the length is here, and some parameter it's completely easy to check. So when you decide that, for example, is 101, you can press the hammer here, and this tool is a copy in my setup. I have, if you want, and if you remember, or if you see the number completely easy, I can also write it. I have not to open every time the table, my tool list, and so on and so on. It's not necessary, of course. And here you have speed, entry speed, and rotation speed. What is this? This is the entry speed is in the Z. The ZX goes down on the inside in the panel, and ask me for how many kilometer per hour, it's not kilometer per hour, but it's meter per minute for the speed, because they can go down slowly or fast. And the other parameter is the speed, is the rotation speed. So how many RPM we do with this tool. And it depends about the tool, it depends about the maximum speed of the tool, about the material that we are working. So there is a lot of parameters that we have to set. It's not necessary to set this parameter here if you don't want. I mean, if you want, it's not a mistake. I can say 0.5, for example, is a good number for entering inside in the wood. So it's a 0.5 means half meter per minute. It's slowly down, okay, and must be slowly when you go inside with the tool. When you move in the tool inside in the wood and you are already to the depth, you can increase the speed, no problem. But when we go inside in this way, slowly down. And we speak about the tool, I repeat, in another lesson. Rotation, you can be between 3,000 up to 22,000, the range. It depends about the tool, I repeat, and some parameter. For example, can be 18,000 RPM, can be a medium velocity, a medium speed of the spindle. If you don't write, it's not a mistake. If you don't write anything about the speed, means you accept the speed of the tool. When we create a tool, you will see we have the possibilities to say what is the default speed and rotation. So when I don't specify nothing here, when I don't write nothing, means okay, take automatically the tool parameters, and that is. But I repeat, we go on depth about this point. And I confirm. When I confirm, means that the line will be written, and I have the position. I can also visualize. Just a second. Okay, it's enough. And now I have the tool here. So in this moment, with this line, I have the tool is working at 18,000 RPM. So the main motor is on. It's on the position minus S minus 1, means minus 20 millimeter from the surface of the panel, at minus 50 millimeters. So I'm around, I am far away 50 millimeter from the edge, the corner of the panel. This is the situation that I have now. So what I want to do now, I want to move with the tool and make this part, cut the base of the panel. Okay. I come back with the view, with the general view. So I need something that bring me the tool in this position. And what I need for do this? I need a line. You don't have a lot of lines, you have just one line. So it's not necessary what you press here. What do you press has the same result every time that produce a line. Nothing else. Depends about what do you know about the point of the line. Okay, so this kind of line is just because you can know something different to explain to the machine what is the arrival point of the line, the end point of the line. Normally, we use the first one, because in the first one you can see when I switch, we don't set the starting point, but just the end point, because the starting point we know already by the setup, so it's not necessary to write nothing here. It's completely lose time if you write something here. So the end point will be the final point. And what is the final point here? What do you think about?
LF plus 20.
Okay, not correct, but I like it. I will explain. LF plus 20 is a good answer. It's not correct, but it's good. It's a good answer because you think about maybe the best is if you write plus 10, because we know, or is not 10. We know that the tool diameter is more or less 15. Okay. So if you want to go completely through, yes, you can say also plus 50, no problem, and you go, for example, in this position. But what we want to do is we start outside from the panel, but here I want to go and go in the vertical line. So my position must be in one point that is the length that I want to reach. So here you just need to say LF. So I will cut, for example, if the panel is longer plus, I don't know, 5 millimeters or 1 centimeter more, it doesn't matter. I will arrive to LF. LF, it's 1000, sorry. So anyway, I will arrive to this point and go in vertical. So I give you the perfect dimension of the panel. So what happened here is I arrive to this point, and now I need another line because I want to reach this point. And this point has the same x like before, it's x LF. But I need to write, no, it's not necessary because I don't move it. What I move is the y-axis. And what is the number that you have to write in the y-axis, in your opinion?
HF.
This is a good answer.
Right.
And correct. Okay, and I am here. So now I just have to come here. Another line where I want to ask, sorry, I don't push. Okay. What is okay, the x-axis is the x that moves because the y-axis stay in the same position. What is the number that you have to write for the x here? Do you know what is this position?
0.
Yes. And then the last movement, another line. I need to move the y-axis, and I will go to 0 again. This is 0, so can be 0, it's okay. I just put something with the minus because I want to pass a little bit over the point. So it's completely clean and well done. Okay, this is the work that you have to do. Now, if I change something in my panel, and I save my panel, but I change something, for example, the depth or and also the thickness can change. No problem. I format every kind of dimension. Okay, what I have here, because it's not finished the program, there is some mistake if I don't finish the program, because I can visualize, we know that we are using a tool, the tool has diameter. I can check for the tool compensation of the diameter because we have. And if you can see here, I have a big mistake. Because in the program that I done, this is my line, the tool compensation is in the middle. So the radius of the tool is completely on the middle. If I produce a piece like this, the piece will be little than diameter in the length, diameter in the height, so completely wrong. So the question is, I have to calculate myself the tool compensation? Of course not, because the software makes it automatically. And the way to say to the software that I want to stay outside or inside, it's the setting is in the setup. In the setup you have, in the advanced technology data, we open, and I have this. This is the compensation of the radius. We have three possibilities. Off means in the center. Left or right. Why we speak about left or right and we don't speak about inside, outside? Because in AlphaCam, it's we have an evolution of this concept. So in AlphaCam you have inside outside because AlphaCam understand what is closed, geometry closed is called, and geometry open. In the software of the machine we don't have, but it's not a problem because I want to explain. The direction of the movement in this moment is this. This is the starting point, and this is the maximum point. So we are working in this direction. So from left to right, this is the movement of the machine. And the movement of the machine means if you want to stay outside, you want to stay here. If you want to stay here, you must be on the right side of the system, of the line. Because if you stay on the left side, you stay inside here. So I go on the setup, and then you can also try, because it's very easy to see after. I stay right, and I confirm. If I switch on here on the view, on show, I want to see the tool compensation, and you can also make it this way. Just it's also here, you can see it's the same icon. Huh? Now it's out. It's easy to see because you can see the sign, it's completely out from the line. No problem, because I can also change in inside and you can see the difference. For example, here I can say left, confirm, and then another time tool compensation. Now it's in. So the completed diameter is inside in my line. So here I have to set like outside or right. Of course, if you program the machine with another way to move.
And off, it's in the middle then.
No, it's not in the middle. You have to switch on the.
No, but I mean, if you don't choose left or
Right,
right, then it's in the middle.
Right.
Center of the line.
Right. So every time you must tell to the software it's in right or left. Of course, yes. But the good thing is, I repeat, I save this program and I can run this program for every kind of dimension because it's not a problem. And you can change the dimension not just inside in the program. So it's not necessary to come here and change it, because the changement can be done also directly when you launch the program in the VSC. But about this we speak about, because I will explain. So now we save the program, and there is another little mistake, but let me before save the program, in my directory training TPA. Okay, this is format all panel. Okay. If I run this program on the machine, I will explain you what happened. Everything is more or less okay. So the two compensation works. And I have back a panel that the dimension will be 1500 millimeter and 600. Okay, everything okay and good, perfect. But if I start the program in this way, I will see something like this. In this place, in this part, and this, so you have the stops here of the machine. So you will see here and here, the machine touch and don't touch the panel. And here we'll cut the total of the amount more of the panel. For example, I take a panel 1010 and 610. So I have 10 millimeters for each part to take out, to route. The completely part will be here and here. And it's not good, because for sure I want also to eat something here and here also, because so the knife fits better and the perimeter is better, and so on and so on. How to do this? Very easy, because in the general view, this one, I have a lot of information, and this one, it's the changement, for example 2 and 2 or 5 and 5. In this way I move the 0.5 millimeter and 5 millimeter. What I mean, you don't see nothing, just it's a set. Means the machine will take out here 5 millimeter in this place and 5 millimeter for sure. What I have more, it's here and here, doesn't matter. Can be 5 if it's 10 more, or can be 4, or can be 6, doesn't matter. What is important is the end dimension is perfect, and what is important is I cut something also here and here.
Is that called offset?
Yes. Offset means how many millimeter you want to trim here and here. It's really important. For example, you can also say here, for example, 2 millimeter. It doesn't matter, because it doesn't matter if the machine will work 2 millimeter and 8 or 10 and 8 or 10 or 11 or what else. It doesn't matter. And when we save the program, I repeat, the same program can be used for every kind of panel, because when I save it and I go to the VSC, I open my, for example, new program here, and I ask to have this one, format all dimension. In this moment I have this dimension, but it's not necessary to go inside. I can also say, okay, now I have this, and I don't know, maybe this, and this is 25. I start, and everything is automatically. So it's very easy. So I have the main program that can have the dimension that like I created. But every time I can produce several lines with the same program inside, nothing else. For example, like this. But instead to say 100 and 500, I have another kind of, I don't know, maybe completely different also, it's okay. So I have the same program, but with different dimensions. Okay. Okay. So, can you wait just a second? I tell to my colleague one thing. Just a second, sorry.
Oh.
See?
Sì, buonasera, sono Francesco.
Salve Francesco, guardi, ho al telefono una persona, la posso richiamare
Sì, sì,
verso le
certo,
5?
certo. Sì, sì, va bene, va
Grazie
bene.
mille, a dopo,
Ok,
a dopo.
grazie.
Okay, sorry, was a colleague. So, in this way, we have the possibilities to use not too much program and to change just some parameter. Okay. Of course, about the router, you can say a lot of things, really a lot of things, because, for example, I make it like an exercise. I don't think you will work in this way with the machine because you have also AlphaCam. But
Yeah.
as I told you yesterday, we must know all the tools. So, for example, I want to make a rectangular or a triangle here in the middle of the panel. How to do this? We make an example, and then you can exercise yourself. I take another time the setup because I take the setup because I want to move inside in the panel. So I cannot take a line because if we take a line from this point, the line will be in the middle of the panel with the z-axis completely down. So when I finish a perimeter, I have to came and to call again the setup. And for example, I want to go, I don't know, LF divided 2, 100 millimeter in the Y. Z can be minus 5 millimeter. Tool the same, or I change the tool, and I am here. After this, I want to go minus 100 millimeter in this position, so it's a line. The final point can be LF minus 10, 100. And then the same in Y. So for example, I want to go, the X is not a mistake. If I make like this, it's okay. Doesn't make, it's not important to rewrite again, but it's possible to do. And that is, and then I go, for example, 100 millimeter. And I go down 100 millimeter. And then I come back to this point because this is the middle point. And I finish in YX LF divided 2. And also in this way, what I produce is something that is completely parametric. So of course you can play with the software as you want. And for example, it can be interesting to understand, okay, but how can I make a triangle here? For example, I want to save it. Format plus rectangular. If I want to make also a triangle, or for example, I want to delete this part. In this moment I don't use. So to delete a part, I have several ways. Like we spoke about yesterday, we can select the parts, and with the shift of the keyboard and the mouse, I can select in this way. Or I can go in the line, the first line. I can see the line where the new perimeter starts because it's a setup. So this one is the format, and this one is where the rectangular inside starts. I can go also in the line number 6. I can press the shift and select in this way as I want. And then I can push this or delete on the keyboard, it's the same thing. So I can delete a part. Or I can also say that I want this part that remain on the drawings because sometimes I can use or not. So I just want to deactivate this line. Is it possible? Yes, because I can deactivate in this way. So if you run this program, this part is blind in this moment, is hide. So the machine doesn't know that it is, and make just the format. But in the program, when I save the program, this part is inside, so everyone can be is able to switch on when you need. For example, in this way, I switch on again. So activation or deactivation of some lines. Okay, now I want to deactivate it because I want to produce a triangle. To produce a triangle is the same thing. This is the first point, so setup. I put LF divided 2 because I start from this point, 100, and the depth, minus 10. Tool 101, that is. And now I go, for example, endpoint, LF minus 100. But now I need to go with the 2 axes. I mean, this is the point that I want to go. And this point it's LF divided 2 in x-axis. And in y it's HF minus 50. This point is 100. So in this situation I have to write 100 and 100. The last segments will be just the x-axis moving in LF divided 2. Also in this case, my triangle is completely parametric because when I change for the measure, follow me. The tool compensation. The tool compensation is in this moment. What is the tool compensation? If I don't know, not very easy to see because outside it's outside in the format, but in the triangle is in the middle. You can see the line is completely in the middle of the routing. No problem because I go in the setup, sorry, and I can open advanced ecology data. I can see that it's off, so good that it's not active, but I can say left, for example, and left. You can see this is the direction, you can see the arrow. So if you have this direction, left is inside. Because this is my program, my line, and this is the way that I program the line. This is the direction. So from left to right. If I walk in this line, this is my right. Sorry. This is what I have in my right, and this is what I have in my left. Okay?
Yeah.
Okay. Of course, better if you understand this concept. Anyway, the system show you because when you switch on, you can see very well. Now it's in. And what happens if I am in? The tool has a delimiter. Of course, I cannot arrive to cover completely the triangle because the triangle has a part that the tool is not able to go in. The system automatically will stop when you have the tangent with the what is completely tangent. So I touch here. If I go over to this point, I destroy your line, and I cannot. So I stop here, and this is 15 point something divided 2. This is the minimum radius that you can have with this tool. Of course, if I have the radius of the tool is 6 millimeter, you will see the same but more near to the corner. Okay, this is the limit, the physical limit if you work with a tool with the radius. Okay, so this is, we save also this program. So you can make again the same program yourself, and this is the point why, because I'm because it's helpful in my opinion to plus triangle inside, compensation inside. Okay, so yeah, we have so the possibilities to make more or less everything inside in the program. We can also say to the program the starting point. It takes 2 minutes the exploitation of this, so and it's enough for today. But if you see in the setup, it's possible to also to set the entry and exit segments. What is this? If I don't say nothing to this part and it's completely not right inside, means the tool make like this. Let me zoom a little bit. Sorry. So the tool goes down in Z, in the same axis, so just go down perfectly straight on the panel. Like it's a bore, like you have to make a hole. This can be okay sometimes, or not. When is not? When, for example, I have a big tool, or I have the tool that is not possible, that bore the panel. And sometimes it's better to use another way to go inside. I want to explain. For example, if I go inside in the triangle, in this point, you can see something after. For example, a little bar. The tool can bar a little bit the wood, because I must go down slowly. And the temperature of the wood can increase and increase also if the knife is not good. Or you can have some tool that doesn't have any kind of knife on the edge. So it's not possible to bore, for example, happen. So I can do several ways to fix this problem. And I can be helpful the entry and exit parameter. I can activate it. Can be a line, for example, or an arc. For example, an arc. And if I put a number, you can see. Sorry. Let me check. Let me see why. Okay. $100 is okay. I don't know why it doesn't work. Let me see. No, doesn't work. I don't know why. Let me see why it doesn't work. Let me see. Yeah. I have to test in your version why it doesn't work, or maybe I'm wrong. I'm wrong something. No, this is okay. Left is. Mm-hmm. Another millimeter is enough. I want to see if I put. No, doesn't work. Doesn't want to make in this way. Okay, I will check in your version, because maybe I'm wrong. Or we have to activate some options. I have to see in your version what happened. Okay, but in this way you will see when it works that, for example, an arc will be done in this way. So to arrive to this point, I don't start directly in this point, but I can start in this point, for example, and make an arc, and then make the rectangular here, and then escape in this way. So the starting point and the end point can be managed as you want. Okay, for this, the next time I will make some tests, so we fix the problem. Okay, so for now it's more or less okay. You have some sample, of course. You can add here holes, so I can go here I move in the last line. I go in the last line, and I can add something. For example, I can make another routing or another hole, or start with the hole. So it can be interesting for the next time if you try yourself to produce something. So we see if what we arrived today is more or less clear, or there is some problems, some mistakes, or something is not clear, and so on and so on. As you want, you can produce as you want, no problem. You decide, and so you can show me, if everything is okay or not.
Okay. Yeah, I can try to copy what you did today and yesterday.
Yes.
That's the most effective way of learning, I think.
Okay.
Because
normally, when, for example, if you make some training on the software, you have something to ask, it's not necessary that you wait the next time that we fix the appointment. You call me, no problem. We work also tomorrow morning, so no problem, or Monday, when you want. Why you try yourself a little bit? Yes. But don't spend too much time. If you don't find the solution, call me. Okay, you have the number, so no problem to call me.
Okay, good.
Okay, that is for today. So it's okay. The next time will be the next week, if you want. If you want to wait the next week to fix a day, we wait. Or if you already know when, it's also possible.
I think the key is the most important thing right now. To get the key.
Okay.
And to make AlphaCam work.
Okay, so if you want to wait the key, I'm waiting for you that the key comes in your hand, and then we make also the AlphaCam parts.
Yeah.
Okay. So I just waiting for you and for you about this.
Yeah.
Okay. Good.
Okay. Thank you very much.
Okay. Thank you to you.
And have a nice weekend.
You too. Thank you very much. You too. That is.
Okay.
Bye, Damiano.
Okay. Bye.
Bye.
See you
next week.
soon. See you soon. Have a very good weekend. Yeah. Thank you very much.
Yeah.
Bye. Bye. Bye.